Unit 11 is going to be more trigonometry, but this time it's going to be on the coordinate plane. So we have this circle that it will create. We should have learned now that an angle in the standard position is having one ray, called the initial ray, on the x-axis, and then another ray opens up like a hinge and can go all the way around, and it goes counterclockwise when it's a positive degree angle. So now we're going to learn about what a reference angle is. And a reference angle is an angle formed by an angle's terminal ray and the x-axis. Circle this, star it, something. That's the most important part here, is knowing it's always with the x-axis. I'm not using the y-axis. So what it will create is our final answer of the reference angle will always be less than 90 degrees. So I'll show you. Number one, we have a 54-degree angle. We know that this to here is 90. So 54 is a little more than halfway. So let's just say it's about here. So create your terminal ray here, and I'm opening up 54 degrees. So our reference angle, I'm going to put REF angle, is going to equal the angle formed with the x-axis. Well, this is easy when it's in quadrant 1. It's literally whatever this angle is. So in quadrant 1 here is just whatever the angle is, because you're away from the x-axis. Let's go to number 2. Our angle's bigger. It's 127 degrees. So we know that our initial ray starts here. This is 90. This is 180. And so I'm opening up past a right angle, past a 90, into 127. So let me think here. What's between 90 and 180? That would be 135 in the middle, so a little less than that. And this will be guided. You'll be able to just drag this point until it tells you. So let's put that this is 130 or 127 degrees all the way from here to here. The problem is, though, I don't want that angle. I want the angle formed with the x-axis. So now that I'm in quadrant 2, I'm going to use the x-axis here at the 180. So I'm actually trying to figure out what is this angle. So what I do is I take 180 minus 127, which would be 53 degrees. So right here, this is a 53-degree angle. So it's like a section, like this is half a pie. 127 was here, 180 is here, so I subtract them to get the difference. And again, it should be less than 90 degrees because we're always within one of these quadrants. Okay, number 3 gets a little bigger. Now we have 233 degrees. So we're starting here, opening up past a 90, we're opening up past a 180. We're not quite to 270 though. So we're somewhere, so 180 plus 50, we're somewhere a little more than half like this. So think about all the way to here is 233 degrees. You could also put it on the outside if that makes you feel better, all of this. But again, I want to know the reference angle that is formed with the x-axis. So when I'm in quadrant 3 here, I want to use the x-axis right here at my 180. So now that I have a bigger angle, I'm going to have to subtract 233 minus 180 to get my reference angle, because I'm past the 180. I want to find the difference here. So 233 minus 180 is 53 degrees. So this angle is what I'm talking about right here. This x-axis with this terminal ray is what I found. So you should be noticing quadrant 1, easy, it's just the quadrants in. Quadrant 2 is taking 180 minus your angle. Quadrant 3 angles are taking your angle minus 180. This one is in quadrant 4, which is IV. Quadrant 4, 338, almost a 360. Let's put it somewhere in here. So we know this whole angle, but my reference angle is actually going to be formed now with the x-axis here and to my terminal ray. So I'm wanting to know this angle. So now I'm going to use this point as a 360 degree because that's one revolution. I'm going to have to take 360 minus 338 to get the angle in here. and that would be 22 degrees. So every angle I found, see how it's less than 90? That's kind of your hint there, and you're just figuring out what quadrant it lands in, either taking your angle minus 0 or staying the same, 180 minus your angle minus 180, or 360 minus your angle.